So welcome to 2.1. We're in the one variable statistics unit. Today's lesson is on data analysis with graphs. It's pretty straightforward. It should only be about, I don't know, a 20-minute lesson or so. So hopefully you guys have printed this out in advance. This was the homework. You had to come up with, I gave you 11 terms, and you had to match up the terms with the definitions and the graphs and the examples. So let's do the examples first. It might be more straightforward. So these are the words, and let's just put a title here. I don't know, 2.1 data analysis with graphs. All right. The 2005 Canada Census. Which word would be the best example here? Right. Out of these ones here, this is an example of, well, statistics, right? It's Stats Canada. There's a lot of statistics on gathers data and analyzes data. Okay, the heights of students in a class. What word best describes that? Continuous variable, interval, histogram, pictograph. Should be pretty straightforward. I'm just going to call on people and force you to answer, okay? Because I'm not getting too much response. Ronaz, what do you think?
For the height?
Yeah.
I think it's continuous.
Yes, continuous variable. Again, these are just examples. Continuous variable. Okay. The number of students in a class. That's an easy one. If it's not continuous, it's Sahil, what do you want? Discrete, right? Because it can only be integer values. 34.5 to 39.5 is an example of Sahil?
Interval.
Interval, yeah. All right. So it's pretty basic things. And then there's some charts. Okay, the first one's pretty easy. I don't know if you were able to print the chart, but let's zoom in about it. And it's very easy to come up with the answer to this one because the answer is right there on the y-axis there. So what would you call this? So it's recording the frequency, but it's not. Well, the answer is right there. It's cumulative frequency diagram, right? So cumulative frequency diagram. So it measures all, like let's say for example this is a test, and if this test score was 115, how many people had a score of 115 or worse, up to 115? So that would be 600 people got a score of 115. They didn't all get 115. Some of them got 110. Some of them got 95. But altogether, 600 people got a score of 115 or lower in a cumulative frequency diagram. Right? So same thing here. It's a diagram, but it's not a cumulative frequency. It's just a frequency diagram. Okay, it's just the actual number, but you're not adding them up, right? You're just they're just each so for example, 115 cumulative with 600. This is about what is this around? This one is around 70 or something for just the people that got 115. Okay, so this next one, let me zoom out a bit. So this. What type of diagram is this when you have bins and and heights and what do we call that?
A histogram. It's
a histogram, but we're just going to be. So anytime it's like that, it's a histogram, but it's relative frequency. It's not. You're not doing. Basically, it's probability. This is what this is. So it's a relative frequency histogram. I don't know if that was one of your options. I don't think it was. Okay, so the options were, it is a diagram, of course. A histogram is a diagram, but that wasn't part of your options there. So this one here, when you represent data using pictures, pretty easy. It's a pictograph. Yeah. Right. This one you've seen lots of times before. Two names, I guess you could call it, and obviously it's this one, right? It's a circle that also looks like a pie, so circle graph or pie chart. Right. This is not a histogram. This is a
bar graph.
This is a bar graph. And what's the difference?
A histogram is attached, and a bar graph isn't.
Yeah, histogram is continuous numerical data, where a bar graph is not numerical data. It's other characteristics, but not numerical data that can't be continuous. So you have to separate them. And this is, again, it's just a histogram. It's numerical data that's continuous. They're connected. But the difference between this one and this one, what's the difference between these two? So this says...
one of them is discrete data, the other one isn't.
I think they're both discrete. The test scores would probably be discrete. But no, it's the y-axis, right? This is relative frequency, where this says number of students. So it's not relative; it's just absolute. So this is just a frequency. It's not relative frequency; it's just frequency. How many of them do you have? This is how many do you have relative to the whole population, right? So I guess, was that an option? No, there wasn't an option. So again, it's a histogram, but it's also a diagram too. So. All right, so that's that first page. Pretty straightforward. Can we go to the definitions page and just wrap that up? So we already said a variable that can have an infinite number of possible values is a continuous variable. B. Diagram such as a histogram that shows the running total of the frequencies. So a running total. What's the key word there? It's
total.
It's the running total. So you're adding stuff up. So it even says the key word is right there, cumulative. So it's a cumulative. Cumulative frequency diagram. Could be a histogram, but anything that shows the total up until that point, something like that. The gathering, organization, analysis, and presentation of numerical information. It's what this whole course is about. You could call this course data management, or you could call it a course on... Does anybody want to finish the word? Statistics?
Statistics.
Yeah. All right. A diagram such as a histogram or frequency polygram that shows the frequencies with which different values of a variable occur. Well, if it's just frequencies, not relative frequencies, we'll just say in general, it's a frequency diagram. E, a variable that can take on only certain values, often integers within a given range. So it's mostly integers, but it doesn't have to be integers. But the idea is it's not continuous. So if it's not continuous, you guys know the answer. I'm just going to not take too much time here. It's discrete. F, a chart or diagram that represents quantities whose bars whose lengths are proportional to the quantities can be used to represent all kinds of variables, including the frequencies of separate categories that have no set order, such as hair color. So basically like the histogram without numerical quantities on the x-axis, right? So what would you call that? A bar graph. A diagram such as a histogram or relative frequency, I don't know what the heck a relative frequency polygon is, that shows the frequencies of values expressed as a fraction or percent of the whole data set. So it's the key word there is relative frequency diagram. So that would be anything that shows relative frequency, basically probabilities. It would be that type. It doesn't have to be a histogram, but could be a histogram. A bar graph in which the areas of the bars are proportional to the frequencies for various values of the variable. The bars are connected and represent a continuous range of values. Everyone, what is it? Everyone?
Histogram.
Histogram, all right. I'll just punch these in. This was interval. You guys can read it on your own. This one here was circle graph, or a pie chart. And the last one here is a pictograph. All right. I think that was pretty straightforward, right? There's just some definitions of some different types of graphs, the different ways of displaying information. Okay. Are we good to move on? Let's move on to the worksheet. All right. So, let's do an example. Let's create some of this stuff. All right. So, can everyone have this sheet ready? All right. Here's an example. Here's a set of class marks in percent obtained in a data management examination. Is the variable continuous or discrete? What do you think? Moranaz, is it continuous or discrete?
It's discrete.
It's discrete, but it doesn't necessarily have. You could theoretically on the test get an 89.02, but that's not how most marks are entered, right?
Yeah.
Most of the time it's typically discrete for marks. But that doesn't necessarily have to be so. Marks could be continuous, but I mean, it could be continuous, but not normally so. Yeah, it's pretty much discrete. All right. B, why would you present this data in a grouped format? So if you're making, if you're trying to analyze it, why would you arrange it in groups? So basically, you have a range of data. And like if you only had two outcomes, everyone had either an 89 or 71, you wouldn't put it in groups. But if you have a large set of data with, covering a wide range, then you would tend to put it in groups, right? What interval width would be convenient to use, and how many intervals would there be? Does anybody, from reading the book, does anybody know when you display a histogram or so, how many intervals there should be typically to make it convenient to look at? Does anybody recall?
No.
So I
what's that?
4.
4, yeah, they don't recommend 4. 4 is like too little. If you read the book, it says normally 5 to 20 intervals.
5.
More than 20 is getting too much to understand, to comprehend. Less than 5 is not really worth it. So the book recommends normally 5 to 20 if you're making a histogram. So we don't have, the marks aren't going from 60 to 500. It's just going from 60 to 90 something, right? So we'll just choose a small range. We'll just choose 5 bins, okay? So let's just see what our range is first. Our range is, what's the highest one? I think
97.
97 is the highest one. The smallest one? I see a 55. Is that the smallest one? Yeah, 55 is the smallest. So if you subtract it, you get 42. We have a range of 42. If we use 5 bins, what should our interval be? What's a nice convenient interval? So we have a range of 42. I think a nice one would be our interval width would be, I think, 10, right? If you have 10 times, if you have 5 bins of 10 each, that's 50. That's at least, you want more than 42, right? So let's make our interval width 10. All right, so let's do that. You don't have to. You can make histogram any way you want. You could make it up to 20 intervals, but that's too much for this data set. So let's just make it nice and simple. Our chart down here only has room for 5 bins anyway. So, all right. So the thing here is, where do we cut? What would be a nice cutoff? Like, where do we start? What would be the lowest interval?
55.
55. So I mean, this would have, yeah. So this would be like an interval, not just one mark, like a range of marks. So what would be the lowest range of marks that would be a nice, easy way to do it?
Maybe
55 is the lowest one.
5.
Oh, a range of 5? No, I thought, like, since we were only going to use 5 bins and it's a range of 42, that we'll settle on 10. Because that 5 times 10 is 50, so we have a range of 50. So why don't we start at 50 and go up to 100? 50, 60, 70, 80, 90, all the way up to 100, right? Now, there's a little bit of confusion, because what happens if you put down 50 to 60, and then here 60, 50 to 60, and then here 60 to 70, where do you put 60? Do you put 60 here, or do you put 60 there? Does everyone see the confusion? If you put 50 to 60 and 60 to 70, 60 appears twice. So let's avoid that. Okay, let's avoid it. So how can we avoid it?
You just don't do it.
61. The next one says 61 too.
There's different ways of doing it. I'll show you 2 ways of doing it. But let's not make the intervals end up let's not have any of the intervals end up on any of these numbers. All right, so one way you can avoid it is, why don't we do 49.5 to 59.5? See, we have no decimals here, so if we end up in decimals, we know we're not going to have any confusion, right? Does that make sense?
Yeah.
So then we can just do 59.5 to 69.5. 69.5 to, if you don't like this idea, there's another way of doing it. I'll show in a second. So, and why are we doing it this way? Because I'm just going to write for the people that aren't here. The decimals are used to avoid confusion. Example, if 2 intervals were 60 to 70 and 70 to 80, where would you put 70? Would 70 go in the first bin, or would 70 go in the second bin? So that's why we use bracket decimals. There is another way of doing it, and that's, or we could use bracket notation. I'm running out of space here. Notation. Does anyone know what bracket notation is?
Yeah.
Okay, can you tell me what it is?
Is it the square thing?
Yeah, one square. There's 2 types of brackets: square bracket and a round bracket. Do you know what the difference?
Wait, sir. So if it's round, then it's not included.
That's
Or
right.
then it's included. Square is if it's included.
Yeah, so the square is included. So you could do, we're gonna, if you don't like decimals, you could say we're gonna include 50, and we're going to go to 60, but we're going to go up to 60 and not include it. Does that make sense? And then here we're going to include 60. So this is OR. We're going to include, let me just zoom in here a little bit. We can include 60 and go up to 70, but not include 70. So 70 would have to go in this one, right? And then here we'd include 70 and go up to 80. Include the 70, but not the 80. Here we would include the 80 and not the 90. And here we'd go to 90, include the 90, and what would the notation be at the end here?
Oh, it would be infinity, right? No, never mind. It would be a round bracket.
Yeah, we're going up to, what's the highest? We're going to go up to 100, right? Nothing's over 100. But to be proper, what should the notation be?
Oh, the round bracket.
Well, actually, let's include the 100. Okay, right?
Okay, that's as far as it can go up.
Yeah, because that's as far as it goes. So the lowest digit, the lowest number, and the uppermost number should have the square brackets. So anyway, you can either use this, but a lot of people don't understand this. So to avoid confusion, they can do it this way. Like, you don't normally see this in generally in the media when you see things in the newspapers and stuff like that using brackets like this. So most of the time they use this. So can I just make a little note way at the top? So I'm going to make a little note about bracket notation. And the note is that bracket and that bracket means include the values, and round brackets means does not include. Alright, so you can do it either way. You can do it with the brackets or use decimals, but you want to avoid confusion where you have a number like 60 or 70, and if you didn't use the brackets you wouldn't know where to put it. Right. Alright, so let's use this one. Okay. So the midpoint of I'll discuss why we're asking for the midpoint later. When we do one of the diagrams, we're going to require the midpoint. So what's halfway between 49.5 and 59.5? It's pretty easy for you guys to figure out, right? No? I guess it is. I guess it's hard. It's 54.5, right? This one here would be 64.5. This would be 74.5. This would be 84.5. This would be 94.5. Tally means frequency. Tally means frequency? So why do we have frequency? Okay, tally is one way of getting the frequency. So you just count up how many do you have in the range of 50 to 59. 50 to 59. So you have, if you do it, I think we just have one, right? 55. Between 60 and 70. Between 60 and 70. The reason we have a tally is you just go over here and you just count. You have one. Well, you would just, as you see them, you would just count them, and then once you get groups of 5, you just take my word for it. There's 5 of them, and then when you count the other ones, if you're doing it, counting them one by one, you would end up getting, I believe, that many. And if you're doing 80 to 90, you would get 4, and if you're doing 90 to 100, you would get 2. So just tally is just same as frequency, but you're just making a mark for every time you see one. So this is 1, this is 5, this is 8, this is 4, this is 2, and if you add them all up, this should be 20. Cumulative frequency. So how do you make this chart? What's the first number here? So what it's telling us, what are the total marks that are 50 to 60 or below? Well, there's only one, right? What would this number be? The total marks that are up to 70 would be this one and this one, right? So they would be just adding these two numbers. The total marks all up to, but not including 80, would be these 6 plus these 8, right? So there should be 14 marks below 80. There should be another 4, 18 marks below 90, and 2 more from 90 to 100. So it should be 20 marks all below 100 or altogether. And these two numbers should always be the same. How do we get the relative frequency chart? Well, it's just how many are in this category? Just 1 out of 20. So it's 1 out of 20 is 5%, right? So this is going to be relative frequency. Again, we're talking about not this column, we're talking about this column. So it's 5 out of 20. This is going to be 8 out of 20. This is going to be 4 out of 20. This is going to be 2 out of 20.
Dad.
Yeah?
Dad?
Yeah?
Uncle Guido's here.
Oh, really? Okay, I'm in the middle of a class. I'll be about 10 minutes.
Well, just tell them you need to go.
Oh. My brother just showed up, so why don't we just finish the lesson? It shouldn't take us too long. So,
Please, go if you want.
this is going to be 0.25, 0.40, and so those are all the relative frequencies. And so total is going to be what? You don't have to think about it too much. Add up all the relative frequencies. It's going to be 20 out of 20, which is 1. Okay, next page. Let's just make some graphs using this. So I'll keep this aside and go to the next page. It says construct a frequency histogram. Okay, so I'm going to make it two things. We're going to create a frequency histogram and a relative frequency. And we're not going to make two separate charts. We're going to make one chart, but with two y-axes. We're going to have and here we're going to have frequency, and here we will have relative frequency. Yeah, I know, but I'm in the middle of a lesson.
So we can continue this tomorrow.
It's okay. I see. What should I do, guys? He's coming
You
over.
can go, it's okay.
Sir, I think you should go see him.
No, it's okay. It's okay.
Exactly.
It's okay. We're almost done.
No, sir.
He can,
Sir, we'll be here tomorrow, but he's only there right now.
You're not going to be here tomorrow. It's Saturday. I'm just going to finish this. It's okay.
I'll come tomorrow.
So, what's our highest frequency? I think our highest frequency was 8. So, 2, 4, 6, 8. And what does it? A frequency of 2. What does that correspond to? That was 10%. 2 out of 20 is, this would be 0.1, right? This would be 0.2. This would be 0.3. This would be 0.4. Right? All right. So how many people do we have now? How many of you guys are there?
7.
7? Okay. So let's put our bins. We have 5 bins, so let's make 1, 2, 3, 4, 5, and we'll start with the lowest interval. And then we're just going to make little diagrams, little bars. The first one was just 1. The second one was 5. Pretty easy to do a histogram. It's hard to. I couldn't really find an easy way to do it in Excel. It's very hard to do it in Excel. I couldn't do it. Next one is what, 8, and then we have 4, and then we have 2, and then these corresponds to the relative frequencies as well, right? So is there, we should put a scale down here. Okay, so this is 2 graphs, a frequency diagram if we ignore this, and a relative frequency diagram if we use the right-hand scale. construct a cumulative frequency polygon. So we're going to do cumulative frequency. And what are the numbers going to go to? So cumulative, what's the total number of responses? Well, the total frequency, cumulative frequency, goes up to 20. It goes from 0 all the way up to 20. So our scale is going to go 0 to 20. Let's say 20 is there, 0 is there, 10 would be here, 5 would be there, 15 would be there. And I'm going to correspond it to here. So what we actually have to use is the midpoints. So we have to use the midpoints because we're doing a graph that looks something like this. We're creating a line graph. So it's not going to be a bin. It's just going to be, we're going to represent all the ones that are in this range with one midpoint. So the midpoint of 49.5 to 59.5 is 54.5. Like, so this would be 54. So use midpoints. So this would be 54.5. This is 64.5, 74.5, 84.5, 94.5. And how would you do that? Well, you have one value at 54.5, right? And then we're just using this point. Now we have 6 for the first two categories combined. So first 2 is 6. Would be about there. Next one, we'd have a jump of 8, so we'll go up to 14. There. And then we're another 2. 14. Or another 4, so 18. 18 would be around there, I guess. And then another 2. So the cumulative frequency diagram should look something like that.
You leaving?
Yeah, but I'll see them. That's fine. Okay. All right. Hey, Maria. Hey. Can you guys hold on a second? I'll be right back. Talk to each other for a little bit.
Go.
Oh, it's fun.
Krishna, should I join the maxing?
Dude, I'm gonna submit a post. I'm finding pictures right now.
Yo, you're wilding. But I don't even know what there.
Go on the account. You know that Asian girl that they just posted? Her name's Brenda. She goes Emily Clark.
Brenda. Where's
Oh,
Brenda?
it's so funny.
Where's Brenda, bro? I don't see Brenda.
I'll send you her thing.
Who starts this? What the hell? I just beyond.
Okay, I said hi. I said bye.
Oh, fun.
Josh, you there? It sounds like you. All right,
Sir.
all right. Let's keep on going. Again, this is kind of basic stuff. I think it's much easier than probability and distributions that we were just doing. All right. G. What proportion of students had marks in the 70s or 80s? So we're going to use the table. So 70s and 80s would be just that, right? These two columns together, right? So we're going to add 8 and 4. So that, right? So it's 8 plus 4 out of 20 equals 60%. So that's what did we use? We used the frequency column of rows 3 and 4. All right. How many students received a mark of 79% or lower? Again, we used the table. but so 79% or lower. What the answer is staring us in the face? What number do we use? 79% or lower is what number? Well, it's this, right? You use the cumulative frequency. So 14 students got either from 50 to 60, 60 to 70, or 70 to 80. So you use the cumulative frequency. So the answer is 14, and it's the cumulative frequency column, and it's row 3, the third row. Okay. Lastly, are there any patterns or trends apparent in the frequency diagram? What does this kind of look like? We have that name for this. What does this look like? What kind of distribution is this? Approximately?
Continuous.
It's continuous, yeah, but we just had a test on this. It kind of looks like it's begins with an N.
Normal.
Normal. Okay. Awesome. Okay, it appears normal. By normal, I mean the normal distribution, not in the normal context of the word, but the math context of the word. Okay. I think we're just about done. This is just, okay. So there's something called a stem and leaf plot. So let's say, and what is a stem and leaf plot? I don't give you a definition, but it's an easy to construct histogram on its side. Okay, and I'll show you how to do it. Well, I'll just make a little thing. I'm going to make a little chart. And you tell me what this. Okay, I'm just going to put in some numbers. Leave the top blank here. And you tell me how this works. What the magic is behind this. Okay, I'll just do the first few rows. Tell me how this works. I'll tell you, the first part is called a stem, and this is called a leaf. What is the significance of the stem?
Oh, it's the stem and leaf plot.
Yeah, we're making a stem and leaf
That's
plot.
what it says.
So what?
Yeah, this is the
When did you do this?
in grade 5.
Okay, all right. So tell me how a stem and leaf plot works.
I forgot, sir. That was so long ago.
All right. So what's the stem and what's the leaf? Just look what I did and look at the numbers. What's the significance of the stem?
Isn't the stem like the 10 value? Or like, never mind. So it'd be like 105. Or
Yes, this
111.
represents 105.
Wow.
I remember that. But
What does this represent?
111.
111. What does this represent?
121, 121, 122, 123, 127.
So this thing represents 5 numbers, right? So the stem, in this example, we're using the first 2 digits as the stem. And the leaf is the last digit. Now, if you only had 2-digit numbers, then you would use the stem as being the first digit and the leaf being the last digit. But here we have 3-digit numbers. So if you continue on, this would be just 15, 16, 17, 18, 19, 20, 21. And let's see, how many in the 150s do we have? It's kind of bothersome, yeah. I see a 158, a 155.
like, or from smallest to greatest.
Yeah, we could, but I don't have time for that. So 158, 155, 150. So we have three of them. 150, 155, and 158. What about the 160s? How many? I see a 160, so we see a 0. Any other 160s? The 166 there, so there's a 6. How about we just take my word for it, okay? 8, 9,
So I will take your word for it.
8, 9, 9. 6. 5 and a 9. This is a 4, a 5, and a 7. Now try to make these in columns, right? 3, a 4, and a 5. So how is this a histogram? If you turn it like this, you wouldn't have to do this, but if you wanted to make a histogram, you could just,
Wow.
Isn't this amazing?
Wow, sir, I never knew that method.
Did you learn that in grade 5 question?
No, I didn't learn that part.
You didn't get that far?
This is advanced stem and leaf plots here, not basic. Okay, so there's your histogram on its side, right? So it's easy to make a histogram. So the advantages are not only can you the length tells you the frequency, but you can actually recover all the individual values by just looking at it, right? So you can recover each value easily. And the second one is there's no confusion, right? The value of 160, we know it's going to be in this bin, not in that bin, because this is only the 150s, this is only the 160s, so there's no confusion. When placing values into intervals. Example 160, right? So it automatically fixes that problem. So to be honest, before teaching this course, I've never saw a stem and leaf plot, so they're not that common. But anyway, that's what it is. That's all we have for today. That's it. There is a little bit of homework. It's just this part right there. We'll do this part on Monday. Again, it's a fairly easy part of the course, but just continue on with the work, and that's it. I'm going to stop the recording. How many minutes is this? Let's see. How do I get to stop? Oh, 43 minutes, really?